Civil engineering is a professional engineering discipline that deals with the design, construction, and maintenance of the physical and naturally built environment, including public works such as roads, bridges, canals, dams, airports, sewerage systems, pipelines, structural components of buildings, and railways. Civil engineering systems is a discipline that promotes the use of systems thinking to manage complexity and change in civil engineering within its wider public context. It posits that the proper development of civil engineering infrastructure requires a holistic, coherent understanding of the relationship between all of the important factors that contribute to successful projects, while at the same time emphasizing the importance of attention to technical detail. Its purpose is to help integrate the entire civil engineering project life cycle from conception through planning, designing, making, operating to decommissioning. Electrical engineering. Electrical engineering is an engineering discipline concerned with the study, design, and application of equipment, devices, and systems which use electricity, electronics, and electromagnetism. It emerged as an identifiable occupation in the latter half of the 19th century after commercialization of the electric telegraph, the telephone, and electrical power generation, distribution, and use. Electrical engineering is now divided into a wide range of fields including computer engineering, systems engineering, power engineering, telecommunications, radio frequency engineering, signal processing, instrumentation, electronics, and optics and photonics. Many of these disciplines overlap with other engineering branches, spanning a huge number of specializations including hardware engineering, power electronics, electromagnetics and waves, microwave engineering, nanotechnology, electrochemistry, renewable energies, mechatronics, and electrical material science. Electrical engineers typically hold a degree in electrical engineering or electronic engineering. Practicing engineers may have professional certification and be members of a professional body or an international standards organization. These include the International Electrotechnical Commission (IEC), the Institute of Electrical and Electronics Engineers (IEEE), and the Institution of Engineering and Technology (IET), formerly the IEE. Electrical engineers work in a very wide range of industries, and the skills required are likewise variable. These range from circuit theory to the management skills of a project manager. The tools and equipment that an individual engineer may need are similarly variable, ranging from a simple voltmeter to sophisticated design and manufacturing software. Electricity has been a subject of scientific interest since at least the early 17th century. William Gilbert was a prominent early electrical scientist and was the first to draw a clear distinction between magnetism and static electricity. He is credited with establishing the term electricity. He also designed the versorium, a device that detects the presence of statically charged objects. In 1762, Swedish professor Johann Wilke invented a device later named electrophorus that produced a static electric charge. By 1800, Alexander Volta had developed the voltaic pile, a forerunner of the electric battery. In the 19th century, research into the subject started to intensify. Notable developments in this century include the work of Hans Christian Ørsted, who discovered in 1820 that an electric current produces a magnetic field that will deflect a compass needle, of William Sturgeon, who in 1825 invented the electromagnet, of Joseph Henry and Edward Davy, who invented the electrical relay in 1835, of George Ohm, who in 1827 quantified the relationship between the electric current and potential difference in a conductor, of Michael Faraday, the discoverer of electromagnetic induction in 1831, and of James Clerk Maxwell, who in 1873 published a unified theory of electricity and magnetism in his treatise Electricity and Magnetism.